All right, so today we're going to be talking about heat maps and high content analysis for flow and image cytometry in FCS Express. We also have Cindy Hazuka on the line from highcontentreview.com. Cindy's going to take a few minutes and tell us a little bit about highcontentreview.com. It's a great resource for those of us in the high content world, whether it be flow or image cytometry. So Cindy, let me make you the presenter, and maybe you could tell us a little bit more about that.
Okay, sounds great. Hi, thank you. I want to thank everyone for joining us today for High Content Review's first sponsors webinar series hosted by Novo Software. And as Sean said, Novo will be demonstrating how their new high content module for the FCS Express can be used for flow and image cytometry, including images from high content imaging systems, which should be interesting. But before we get going, I'd like to take a few minutes to introduce you to highcontentreview.com. High Content Review was co-founded last year by myself, Cindy Hazuka, and Mike Shostad. And we both have over 20 years of experience in quantitative cell biology and spent most of our career developing tools and techniques for high content screening. A majority of Mike's experience has been on the vendor side, where, for example, he's helped develop and market Molecular Devices Image Express platform, whereas I've been really a high-content super user, developing experiments from conception to analysis and working with vendors and in-house staff to customize processes and build equipment and software. And so both Mike and I really felt that there was really a dire lack of a consolidated place on the web that we could direct people for learning more about high content screening and analysis, and just simply set out to create one. So our initial goals for High Content Review are to really create a focused user group in an interactive website devoted to education and information to people who are new to or frequently using high content screening methods. And what we've done is to kind of create a place where you can read about people and product highlights, references to industry links, learn about technology basics, surveys, groups, forums, membership, the whole 9 yards. And we've put a lot of this background into place. And at this point, I would just like to quickly switch over to the website live and just give you a few highlights of some of the pages we have going and encourage you to participate in the site. So this is highcontentreview.com. It's just simply highcontentreview.com, all one word. This is our home page, which is really where we post short blogs, highlights, things we think that high content users would be interested in. Links that we post here, we actually then broadcast back out on our regular social media. So for example, High Content Review, we have High Content Review on Facebook, LinkedIn group, Twitter account, and when we post new blogs here, we'll blast them out on the links to the blog on those, as well as we have a newsletter that comes out where we like to highlight these articles. And I'm encouraging anyone to contact me if you'd like to post your own highlight. Really would love some contributions for content, or if you even have an idea for one, I'm happy to follow up ideas or leads of things that the users might be interested in learning about. I think right now one of our best resources is on our links page. Here, what I've really been doing for the past year is to try to consolidate links to anything people might be interested in terms of high content screening. And it's all academic and based by category, things like academic research departments, companies that are involved in automation, consumables, education. You even have a category here called open source, where we try to post links to places where people can get free software or analysis tools. And again, really happy to take suggestions of links that are there, aren't there, again, as a resource for our users. One of our other pages that we really would like to build up on are things like our HCA basics page, where we want to post a lot more information about how to do a high content experiment. So what's involved in doing a high content screening, assay development, automation, robotics, imaging, all of these categories. We'd love to have links to more detailed information, and again, are hoping the user community can help us on that. We have a survey tab where we have some ongoing surveys. Again, we have more respondents. We would like to share the information with our community. So we encourage you to take some of our surveys. And there are several other tabs that we're working on, including jobs, where we'd like to have jobs posted, etc. And finally, a word about membership. To become a membership is free, and members can be part of our social network on our website to share ideas and expertise in part of our forums and groups. Right now, everything can be viewed even if you're not a member, but we encourage you to become a member. One of the things you can do is have your profile listed that we've really customized for the HCS user, where we ask things about experience that are related to high content and give you a chance to talk about your experience doing high content screening. And in the future, you also join become a member of our join our newsletter mailing, which we only send out about once or twice a month. So that's all the time I'm going to take right now. If you have any questions, please post them on your GoToWebinar control panel, and I really want to encourage you to take some time cruising around the site and to contact me with ideas or information you might have, and to create an account. So with that, I'd like to turn it over to Sean and his team. Thank you.
Hey, Cindy. Thanks very much. So I've been around highcontentreview.com on the website, and I have to admit it is very useful, and there are a lot of resources there that are great for the flow and the image cytometry community. So we really urge you to take a look at that website when you have a chance. Again, if there's any questions for Cindy, feel free to send them in as the webinar is going, and we'll make sure she can get back to you and answer either now or after the webinar. So we're going to continue now and talk about heat maps and high content analysis with flow and image cytometry in FCS Express. And again, I encourage you to ask your questions in the questions box as we're going along. What I want to also mention about de Novo software, the webinar that you're seeing today, and all the information, this is all on our website as well. It's going to be available after the webinar, so you can always check back there. So in FCS Express, de Novo software, for those of you who know us, we've been around for 15 years. We've been well established in the flow cytometry world. In the last 2 years, with the release of FCS Express version 4, we've introduced a high content or a heat map function and an add-on in FCS Express. And what that means is that for those of you doing high content analysis, those of you who are doing plate-based analysis, anybody that needs to use a heat map for flow or image cytometry data, you can purchase this add-on for FCS Express version 4 and start looking at your data in heat maps. And we're going to show you what that looks like in just a few minutes. High content is supported, or heat maps are supported in FCS Express with all the different versions that we have. In version 4, we had the flow cytometry version, the image cytometry version, and the plus version, which combines both of them. You will also get the high content add-on when you get a free demo of FCS Express from our website. So we'll give you some links for that at the end, but make sure if you want to check it out, you can always go and try with your own data. Now, FCS Express works with many data types. As I mentioned, this is going to work with flow and image cytometry data. As far as we can tell, this works with almost every flow cytometer that we found that has high content. This includes things like the BD Accuracy machines, the BD high-throughput screening system, the LSR, Guava's, Sony Eclipse, the Coulter Quanta, Hypersight, the list kind of goes on. And if you do have a flow cytometer that doesn't seem to be compatible, let us know. If it's standard FCS files, we can pretty much, wouldn't have too much trouble probably getting that in there. Now with imaging data, there's lots of different types of imaging formats out there. Unlike flow cytometry, we don't have the .fcs file standard yet, but we do work with Cell Profiler and ImageJ, which are both free segmentation software tools, which means that you can take any type of image from any microscope with any kind of plate size, run it through Cell Profiler and ImageJ for free, and then bring it into FCS Express. We're also compatible with the entire suite of PerkinElmer high-content imaging devices, so the Opera, the Operetta, Columbus, things like that. And with molecular devices, we're compatible with the Velos and also the MDC store. So there's lots of ways that you can get your data in for free, and there's also lots of ways that you can get your imaging data in from specific vendor formats as well. So also to mention is that the high content or the heat maps are going to work on any size plate that you have. So if you have an 8-well plate, a 96-well plate, if you have a 1500-well plate, you can bring any of those in. The size doesn't really matter in this case. And what we can also mention is that if you're working with imaging data, you can also have multiple fields of view for a well. That means if you have 5 images in a well, or if you have 1 image in a well, all that data can be brought in, and when we're using the imaging software, we can go through that and pick all the different images to look at. So let's start by taking a look at what heat maps are in FCS Express. What I'm going to do is open a new layout. And you notice we have a blank screen here. We're not going to talk too much about the basics of FCS Express. We're going to talk more about the high content add-on. But what I want you to understand, for those of you who haven't seen FCS Express for either image or flow cytometry yet, is that this looks and feels a lot like Microsoft PowerPoint. And this is by design to make everything really easy for you to use. And in PowerPoint, we insert things like text boxes and shapes and pictures. But in FCS Express, we're going to be inserting plots. And the plot that I'm going to insert here, you notice is that we have this heat map option. So if you've purchased the add-on or if you're using the demo, you can just click on heat map. And you can draw an object on your layout just like you would in PowerPoint. And you're going to be presented with a screen to choose what data file you want to look at. In this case, we're going to use some flow cytometry data to get started. We're going to be looking at some image cytometry data later. But you notice that we have lots of different files types that you can choose from in FCS Express Plus, like looking at these BD Accuracy plates, the Velos files against Cell Profiler, general FCS plate folders, a lot of different file formats here that you can choose from. But we're going to choose this BD Accuracy data and click Open. And we're going to let this file open up. This is a 96 well plate, and what we're doing now is we're loading up all 96 wells, or all the wells of the heat map that we want to look at. And one thing I want to stress, when you have these heat maps in FCS Express, again, they're going to work like any other plot, and they're going to work like a PowerPoint object. So if I want to move this around the page, I can certainly just move that around. I can resize this using the handlebars, and I can make this any way that I'd like. Another thing you can do here, you notice that we brought in one heat map. If you want to create a few heat maps on a page, you can right-click and just choose Duplicate Plot. You notice that another heat map automatically appears, and we can move them anywhere on the page that we want. So this is important. You're going to see down the line that we can do lots of things with these heat maps. It's important because you can have as many of these on the page as you want. And I just want to show you the last kind of thing about PowerPoint in FCS Express. So there's lots of export options here. So once you get done with your analysis, you can simply come in here and say save the layout as either a layout file, as a PDF, even as a picture. But most importantly, we really like exporting the PowerPoint. It's a very convenient thing to do. So what I'm going to do is save this on my desktop, open the presentation, and just so you can see how this works, PowerPoint is now opening up, and here it is, and we have our two heat maps that we inserted in PowerPoint. And we can do anything with these objects. They're super high resolution, they're ready for publishing, for posters. You can make these as big as you'd like. So just keep that in mind, that anything that you're doing in FCS Express can be quickly exported and worked with in a Microsoft Office-like feel. Now let's talk more about what we're viewing in these heat maps. So you notice here in this heat map we have 96 wells. We have rows A through H, columns 1 through 12. One thing you may be saying to yourself is, where are all these wells that are not appearing down here? The reason that I like to use this data set as an example is that you don't always run every well in a flow cytometry experiment, or you don't always run every well in an image cytometry experiment. Whatever wells you have acquired will show up in the heat map in FCS Express just like this, and if you chose not to run some of those wells, they won't show up. They won't be included in your analysis. So it's a good thing to note. I mean, if you're running a 1500 well plate but you only have 900 wells for your experiment, you're only going to be dealing with those number of wells. Now, when you have a heat map in FCS Express, one thing that you can do is you can view any statistic on any parameter that you've acquired. When I say parameter, that can be parameters for flow cytometry data or different parameters for image cytometry data. And the way that we look at different parameters in a heat map is just like any other plot in FCS Express. We click and hold on that parameter label on the axis. And you notice here, this is flow cytometry data, so we have forward scatter, side scatter, 4 different fluorescent channels in the area and the height parameters along with width and time. And if we wanted to say change to FL2, we can change to FL2, and you'll notice that this is going to be updating the heat map as we change between these different parameters. You can see that the colors are changing here, indicating that these parameters are changing for us. Now, what you may be asking yourself is, what do all of these different colors mean? And what these colors mean is red is hot, or red has heat to it, or it's a high value. Green is low. That means it has a very low value. And the black in the middle is something, again, that falls kind of around the median of this data. And let's take a look at what statistics we're actually viewing here. Before I do, I just wanted to pause and see if anybody has any questions. The first question we had is, it says, if you run all wells but deem some bad, can they be flagged? I'm actually going to show you exactly that example, how we can flag those wells and also how we can remove them from the analysis in just a few minutes. So you're going to learn all about that, and the answer is yes, we can do that. So let's take a look more into what's going on in this heat map itself. I want to right-click on this heat map and click Format. And when you choose right-click and Format on any plot in FCS Express, you're going to be presented with our formatting window that is going to give you access to any of the formatting options in the software. And a right-click and Format on any plot, including heat maps, can be your best friend in FCS Express. So when in doubt, right-click, Format. And what I'm going to do is I'm going to choose Overlays here. And the overlays is going to show us the information for this heat map. You notice that we're looking at all the wells here. And we also are showing which statistic parameter on the axis. So here you notice we have forward scatter. If we wanted to change, we can do this here as well. We can preview. You notice that this is changing the side scatter and to FL2A on this plot. So another place we can come in and make those changes. But really importantly, what you want to notice is, what statistic are we showing here? So what statistic is this heat based off of? In our default list here, we're showing arithmetic mean of these channels. But we have lots of different statistics that you can choose from in FCS Express, like choosing standard deviation, CVs, median, geometric means. Important things like events, percentage of gated cells. And what I'm going to do is choose number of events. I think this is a very important statistic to work with high content data in a lot of instances. So I'm going to click preview, and you notice that our heat map changed again color because now we're looking at the number of events for this forward scatter parameter. Now we have specific options in heat maps as well. Conveniently, these are in the heat map specific options and color levels options. One of the options I want to show you real quickly is that we can change this to a portrait if we'd like to. So if I click OK, you notice that we actually just switched around the way that we're viewing that heat map. This can be useful in some instances, but if you don't like that, you can always just undo that change, or again right click and format, come back in here and change this back to landscape, and you'll see that that's going to return back there for us. Now we had just had a question about scaling the green to red colors, and that's exactly what I'm going to show you right now about all the different color scalings that we have and the different styles for showing how your data is displayed in these heat maps. Now you notice we have a few options here in color levels for the selected color level, for the style, the color scaling, and let's talk a little bit about this. So the default color levels in FCS Express, again as I mentioned, red is hot, green is cool, and black is in the middle. And what this means is that we're looking at the mean value for, in this case, events for the entire heat map. We're calling that mean value, we're assigning that a color of around black. Now anything that's above that value or below that value is going to be a different shade of red and green, and those shades are indicated as right now 3.5 standard deviations away from that middle value that we determine. So if you were to come in here and change your standard deviation value for this default setting that we have in here, say we'll make it 3, you notice over here on the heat map we're actually starting to see some changes. And maybe if we make this 1, it will be a little bit more extreme. And you can see how this is changing some of the color scaling already. So this is, again, a default way of doing this. It may not work for everybody, but the good thing is FCS Express has lots of options for different ways to view this data. In this case, we're looking at events, so using a linear color scaling is probably a pretty good idea. But if you're looking at data that has a wider dynamic range, I mean, maybe you're looking at fluorescence data. In particular, we're looking at this Accuracy data, which has essentially a dynamic range from 0 to 10 to the 7th. Not that we ever use all of that range, but if you were, you could choose logarithmic. And if you notice when I click Preview, when we use logarithmic scaling, it's going to change things to use that new logarithmic scaling to assign heat to everything. So keep in mind, when you're working with flow cytometry data, you may want to take a look at the logarithmic feature, especially if you're looking at, or the logarithmic color scaling, especially if you're looking at fluorescence data. With events, linear might work okay. And for your imaging data, it depends on what you're looking at, morphometric features, whether you're looking at intensity values, you're certainly going to want to come in and see what's going to work best for you. Now we also have a lot of different styles here for the colorings as well. You're not just stuck with this mean plus or minus standard deviation. What we can do is we can assign a fixed range if we want. And if we choose a fixed range, what this means is we can come in here and assign these color values any way that we like. And again, this first fixed range that we had is defaulted by the software based on the data itself. But what we could do is if we click on our settings here, you notice that we have some increment values, so we can set the highest level for these color scalings, and we can also set the increments that come in here and have this automatically update. So you can kind of come in here and semi-automatically create these increment values, or you could even come in here one by one and change the color value and the numerical value for each of the different color schemes that you have in here. And of course, if you did that manually, you wouldn't want probably a few hundred colors in here. You probably just want a few. But again, we can look at a very similar thing with percentile-based data, or percentile levels. You can use percentile levels instead of a fixed range or a standard deviation, and that, again, that value can be calculated based on the data, or again, it can be calculated automatically or manually by anything you want to insert here. You can see that we have certain percentiles being presented here in the coloring scale, and again, you can come in here and change these at any time you'd like. And the last one here is threshold. I'm going to come back to threshold in a minute because there's a few things we can do with that. But I also wanted to mention all the different color levels that we have as well. So not just the style or the scalings, how we want to display different colors. So a very kind of typical way that people look at heat maps is with this rainbow heat map, where we look at things in the color spectrum that are purple as being very hot or very high levels, things in the red as very low kind of cool levels, and as we apply that scaling you can see how this updates for you. We can also do this, if we were looking at green-red before, we can also look at this as green-blue, again blue being hot, green being low. And we can take this to grayscale levels as well. So if you only wanted to look at things in gray, we can look at very white values as hot and black values as cold, or we could invert that grayscale and keep this the other way around, where black values are very hot and white values are very cold. Now, I want to discuss the threshold as well, and essentially what a threshold is going to do is we can set a value on a heat map, and we can say if the value in that well in that heat map is above this threshold value, assign that well a color. And if I set this as 0 here, you'll see that when I click preview, everything's going to turn to red. Because in this case, all these wells contain events, so of course they're above 0. What this kind of leads me into is I kind of want to know what the number of events for each of these wells are, so I can better set a threshold value. So let's show you how you can come in and look at the statistic values for each of these individual wells, and then we'll use that information to set up a correct threshold, or a meaningful threshold, at least for this experiment. So let's click OK, and we'll keep that there. And again, what I want to do now is look at the individual statistics for each of these wells. And to do that, we can insert a text box here from the Insert General Text Box tab. And in this text box, I'm going to right-click and choose Insert Heat Map Stats Grid. And what this is going to do is present me with options here. Since I have 2 heat maps in this layout, one for FL2A and one for forward scatter, I'm going to choose the one for forward scatter. And what's going to happen is we're going to create a table that's going to show us the events in each of these wells. And in this case, since we're showing the number of events, that's the statistic that's appearing here. All these values are in gray. What that indicates in FCS Express is that these are live updating statistics. It's something that we call a token in FCS Express. I'm not going to talk too much about tokens today, except that they're live updating statistics. We have a great webinar that just made it up to our website, or it's going to make it up to our website later today or tomorrow, about using statistics and tokens in FCS Express. But just keep in mind that these are live updating statistics. So if I were to right-click and format this plot again, and let's change our overlay statistics from number of events to our arithmetic mean, watch this table. When I click preview, those statistics are all going to update in real time to now show us that new statistic that we're viewing in there. And in this case, it's going to be the arithmetic mean for the forward scatter channel. What I want to do is change this back now to number of events. And the reason is, again, what I mentioned is I'd like to set up some sort of meaningful threshold on this data. And again, I'm going to right-click and format in my heat map and color levels and come back to this threshold section. So you can see when we look at this table, there's lots of wells here that have 9,000, 8,000, 11,000 events. We have some wells that have 2,000. We have a well here that has 47 events. So there probably is some data that we want to exclude. Some wells that, maybe the flow cytometer got clogged, maybe our image segmentation wasn't that good, so we only got 47 events. So let's set a threshold of about 5,000. And what I can do is type in 5,000 in here, in this threshold, and what this is going to do is that any wells that have more than 5,000 events or cells are going to be colored red. Any that are below that are going to be colored black. And when I click preview, you can notice that these wells are being highlighted in black. So again, these are some wells that are going to alert us that there is something weird going on with this data. For whatever reason, maybe these are wells that I want to exclude. And as I mentioned, anything can be formatted in FCS Express. So if we want to maybe make all the others bright green, maybe green for go, and maybe red for stop, we can highlight those any way that we like. So this is not just useful for excluding wells or finding things to exclude. If you want to do some sort of hit analysis where you're looking for positive events that fall above a certain median fluorescent intensity, whatever kind of statistic we're showing there, you can certainly set that threshold value here, and what you'll get is a hit analysis on your plate. And you can find all the different wells that were positive for particular hits in your experiment and quickly and easily go back to them for further analysis. So I'm going to click OK here, and we're going to leave this. And where this kind of leads us into the data is, we probably do want to exclude these wells. And maybe we do want to choose some other wells in this analysis to look at. And to choose wells and to exclude wells from analysis in FCS Express, we use something called gating. And I always, when I'm talking to a flow and possibly image cytometry crowd, I always explain gating a little bit. For those of us who are in flow cytometry, it's very obvious what it is. But image cytometry, we use something called thresholding more often. And essentially a gate in FCS Express or a gate in flow cytometry is equivalent to a threshold in image cytometry. But gates can be in more than one dimension. Essentially, if we want to look at two different fluorescent channels at the same time, we can do that. And what I'm going to do now is show you a little bit about gating these heat maps, and I'd also like to show you about other gates in FCS Express and how they can be used. So what I'd like to do is insert a dot plot here. And before we go on, I just want to stop again and see if there's any other questions about anything we've done so far. We've talked about essentially all the formatting options we're going to cover today. So are there any questions about that? And one question that we had was, can you set a threshold, not as a specific number, but a specific well? And again, for example, maybe the threshold value should be the value that's in well A1. The answer to that, the quick answer to that is yes. Through the use of tokens in FCS Express, you can set a threshold based on a token. So you can set a threshold based on any of these live updating dynamic values that are here, whether here or anywhere else in the software. What you probably didn't see in the thresholding is there was a little button next to the threshold that had a T for a token, and that value can be, again, defined through a value in a well. It can be defined by the median of a histogram. It can be defined by some sort of custom mathematical formula that you determine to use in the software, ratios, whatever it is you want to do. So there's a lot of different ways that you can pull thresholds dynamically from your data set and use them elsewhere in the layout or elsewhere in other heat maps. And we'll show you a little bit more about that later as well. So I'd like to continue with gating with high content data or with these heat maps in FCS Express. I'm going to, again, we inserted this plot. And I'm also going to insert what we call a gate view over here so we can see all the gates that we set up. And the first gate I'm going to set up is a very standard gate. We're just going to use a polygon gate. And we're going to highlight, or we're going to encircle all of these cells in the analysis. And we'll just leave this as gate 1. And you notice that when I create that gate, we have the percentage of cells in that gate. It's in our heat, on our gate view over here, and they're all in red. And again, as I move this gate around, these statistics are going to update. Now, a really nice thing you can do is if this is a population of interest and you want to exclude everything else in this analysis, and what I should mention first, actually, is that all the dots in this dot plot represent all of the events in the entire heat map. So from every single well in this data set, this dot plot is displaying all of those events. But let's say I only wanted to look at the events that fall within this gate and exclude everything else. This is one way we can exclude data based on just the dot plot. All we have to do is take that gate, drag it onto a heat map, and you'll notice probably it didn't update too noticeably yet, but that gate is applied, and we can see that if we click on that plot and look up here in the current gate, it says gate 1 is applied. So watch what happens now as I move this gate around. You're going to notice that the heat map colors are going to be updating and they're going to be changing for us because this heat map is now only showing data that's from cells that fall within this gate that we've created on the plot. So this is one way of excluding data. And this may be better for flow cytometry than image cytometry. I'm not really sure. It depends on your experiment, but it is one way to do it, and we can watch all of that update for us. Now, another thing we're going to want to do with this data is probably start creating some gates directly on the heat map itself, rather than just creating gates somewhere else and applying them to a heat map. And this is very easy to do in FCS Express. And let's do that up here, because there's a few things that we probably want to do with this data. So to create a well gate on a heat map in FCS Express, there's a few ways that we can do that. We can come up here to the gating tab and choose well, and then we can just click on the heat map. And you notice that we're prompted to call this gate something. We'll just leave this as gate 2. And gate 2 is now highlighted in blue on this heat map. And if we click on any other well, you notice that the position of this gate or this well gate that we created is moving. And there's a few different ways that we can assign well gates in FCS Express. One is, again, you can just click on these things. Another is we can select multiple wells by dragging a box and drawing a box over them. So we can select multiple wells and pool that data together into one gate. That doesn't just work for rows, it can work for groups. It can work for many groups. And if you hold down Control, you can also click on non-contiguous wells in the analysis as well. So maybe you have different controls in different areas. Maybe I have some positives over here and some positive controls over here. Or maybe you made a pipetting area and you just need to click that one well. You can do that. It's very quick and very easy to do. So let's leave that gate as it is. Let's actually remove this and include that one and click Close. We now have that gate created. Over here in our dot plot, you notice that there's lots of events that are being colored in blue now. And that's because these are all events that fall within this blue gate 2. And if we were to drag gate 2 onto the dot plot, we're now only looking at the events that fall within that gate that we defined. So if I want to edit that gate, what I can do is right-click on this dot plot, choose Edit Gate in Gate 2. And what I'd like to show you here is that as I change this gate, now we're just looking at this well, you notice that all that data on the dot plot, or whatever other plot, whether it be a histogram, density plot, any other plots with any parameters, it's going to change for you in real time. So let's take a look at what's going on up here with these wells. Right? So this well that we've highlighted in our threshold of 47 cells, obviously when we look at that data back here in the dot plot, it looks like there's not very much going on. And again, maybe these wells are a little bit better, but still, since they're below that 5,000 level, we probably want to exclude them. So let's talk about how we can exclude those wells kind of quickly and easily. What I'd like to do is create another gate, and to do that I'm going to right-click and say Create Gate and Well. Again, doing the right-click Create Gate is just another way of getting to this well gate. And if I click on that, I'm going to call this an exclusion. And I'm going to make these sky blue. And what I'm going to choose here is exclude these events. And when I click OK, I'm also going to highlight these other wells here to exclude them from the analysis and click Close. So this exclusion gate now, if I take this and I apply this over to this dot plot, what this is now showing us is every event in the analysis except for the events that fall within those wells that we defined in that exclusion gate. So if I were to come in here and edit this and maybe exclude all these events, you can see how that's going to change our dot plot. So this is a great way to come in and kind of cherry pick which data you'd like to remove. If you're doing a batch process with this data, you could always pause in that batch process to come in here and have an exclusion step to really do some really good high quality control on your experiments as you're running them. So are there any questions about gating or working with heat maps or anything that you've seen so far? Because what I'd like to show you now, now that you've seen the basics of using gates with heat maps and formatting these heat maps, are some further examples of some complex analysis that you can do with these things, with both flow and image cytometry. So if you do have questions, please enter them in the questions and answers box. I'll assume that we don't have any questions. And what I'm going to do is open up some example layouts now. The first example I'd like to open up is this high content data set that actually came from a hypersite. Again, this is a 96 well plate, and we're going to show how we can further analyze some of this data. And one question we just had that came in was how to show a dot plot from one specific well. And that's actually going to be, I'm going to show you that in this particular analysis. So we have these heat maps. I'm going to spare you the details about the experiment, but essentially we have some positive and some negative controls or hits for GFP. We have these overlaid in a dot plot here, and these two populations, the negative and the positive, are actually coming from different wells on this heat map. And over here on this dot plot, we're only showing the positive events for GFP. And let's take a look and show you how we're actually doing that. So when I right-click on this plot and I choose Edit Gate, you notice we have two gates, a negative control and an experimental. And we have these gates applied to these different plots in different ways. And let me show you, just if I show you the gating here, if I right-click and format in the overlays, you notice here that we have this negative control gate, and actually we have this experimental gate shown on this plot, so we're only looking at cells in that experimental gate, and they're being colored blue. So as I come in here and I edit that gate, my experimental gate, here's my gate, and if I change that, notice how the single dot plot is changing, and also how only the experimental histogram is changing in this analysis. And by applying a single well gate to any dot plot or to any overlay in the histogram, that's how you can come in and look at only that data for that particular well. And again, as we move this around, we can watch how that data changes. Now, if I wanted to all of a sudden pool some of this data in this nice histogram overlay that we did, we can start control-clicking on some of these red wells, and we can notice that we're actually having some double peaks here. And the other thing I want to draw your attention to in this analysis is that we actually used a token here to look at the positive versus negative mean fluorescence channels, or the relative intensity of these things, so we know how much more positive relatively this blue histogram is from this green histogram. And in this case, the mean values make this 7.54 times more intense than the green channel. So this is just to show you this layout, how to use, how you can use different wells as overlays, and that this is possible with histograms, and it's also possible with dot plots, and that we can look at these things on a single plot-by-plot basis if we'd like. Now, another thing I'd like to show you today is let's take a look at some image cytometry data. And what we're going to do is we're going to open up our, let's see here, our heat map in image basics layout. And in this particular layout, it's a 96 well plate again, and this data is from imaging data, and the images were acquired just with a standard microscope, and the images were segmented and analyzed by Cell Profiler. And Cell Profiler analyzed this imaging data. It pooled all the data for the 96 wells together while allowing us to still pull apart the different wells for analysis in FCS Express. And in this experiment, just so you have an idea of what's going on here, it is a titration experiment with, say, drug A and drug B. And the really nice thing is, in this experimental design, we have some positive and negative controls, and you notice that they're in the upper rights and lower lefts of this plate map that we have here that's just being shown as an image. So what we can do, or what we've done, is we're looking at all the cells in the entire plate, and then on these two individual dot plots, we're looking at the positive control, or the translocated cells, and the negative control. And this is very useful because we're now able to come in just like we would do with flow cytometry and set an objective gate on the data, saying that anything that falls to the right of this population is going to be considered a non-translocated cell. And that's what we've done moving forward in this analysis using these gates. And when I come to the second page for the heat map data, this is kind of a review page where we actually want to visualize what's going on in all of these individual wells in the heat maps for some quality control for ourselves. In this page of the layout, we have two picture plots. One picture plot showing the cell-by-cell images, or the actual image that came off of that heat map or out of that particular well with a black background, and another one just showing the cutouts of cells. And again, what we have over here is what we call a data grid, where we're looking at a few of the parameters from this data set, and we're actually looking, if you notice we make this a little bigger, we're looking at the single cell cutouts, or the single cells of everything that fell within this well. And what this means is, if I right-click on this heat map, I choose Edit Gate and Single Well. As I move this around, this single well, we can review this data. We can see the image that's associated with that. We can see the single cell data, and we can watch as these percentage values of the non-translocating and the translocating cells change. And interestingly, and as we expected, as we move from left to right, more and more cells become non-translocating. All the protein stays in the nucleus, and you can see that these are very nuclei-defined cells. And again, if we move back to the beginning of the titration, we can really see the difference there. So by using these heat map gating options, we've really been able to come in and zoom in on this data on the population level for that well, and then even get down to the single cell level in that well of what's going on with this data. And when we came down to it in the end, we do have a dose response curve for this particular analysis, and what we've done elsewhere in this layout is we've set up different gates on this heat map. And you look at here, if I say edit my gates, I have gates for a whole bunch of different columns. So if I select column 8, you can notice where that is. But these columns are pulling data and displaying that data in this regression analysis that we're doing here. And as we change one of our gates on a dot plot, that regression analysis is updating for us in real time. And in this imaging experiment, we actually don't have a lot of events for each of these wells. It's only one field of view. So this regression analysis looks a little bit choppy. And what I want to show you is that we can do very nice, very beautiful regression analysis, especially when you're working with data or imaging data that has multiple fields of view per well, or if you're working with flow cytometry data, which inherently usually has a lot more cells. And to show you that, I'm going to show you this last example of heat maps. And this is just a general high content screening experiment. Before I show you the really nice regression analysis, I also want to bring you through a few things that are very important for high content screening, whether you're doing flow or imaging data. Again, one of those is looking at the distribution of negative and positive control populations, so pooling well-based data with gates. Essentially what we did here is what you already saw, where we can pool that data for the negative and the positive controls. But what we really want to get out of this data is something like a z-score, right? That's going to give us a kind of mathematically derived way of showing how good this data is in terms of how far our negative and positive controls are. So in FCS Express, you can calculate z-scores automatically through the use of tokens. This z-score is actually based on a few different statistics in our layout. One of them is it's looking at the median for the values underneath this marker, or from our positive controls. So as we move this marker and say we choose the cells that are very positive, you notice our z-score is going up. And that makes perfect sense because the positive and negative controls are much further apart. We're also reviewing what those positive and negative control wells kind of look like over here in this histogram overlay. But say I came in here to my heat map and I said, let's edit my gate Let's edit my DMSO control over here. If I were to include positive controls in my DMSO control, you can see how all of this z-score is how the z-score is changing, and also how my histogram overlay over here is changing. You notice as I go back here, we're stepping back towards a better z-score. And again, if we include those positive controls, it's going to get worse again. So this is a great way to refine data. I mean, maybe you want to remove a few wells from your analysis. If that helps your z-score and you know that you can throw away legitimately that data, you can gate that out. But again, that falls into quality control, and in our quality control page we've actually set up a few different thresholds. What you had mentioned earlier, or what somebody had asked a question about earlier, is using a token for setting thresholds. We did that in this particular heat map where we used a token to set this threshold, whereas this one we had just manually said let's look at a minimum of 350 cells. And for the flow cytometry people out there, don't worry, 350 cells can be a lot for imaging people. It's not quite a bad value sometimes. And what I really want to show you is what you can get out of this data when you spend some time. You can set up, again, these very nice dose-response curves. In this particular analysis here, we've set up this dose-response curve where we have the DMSO control labeled in purple. It's kind of hard to see here. It's among the other controls or the other things, but there's a purple diamond. We have our 500 nanomolar control, and we can see where that falls in this response as % positive. And then we have our control response and our two compounds. We're getting the minimum and maximum values automatically calculated, as well as the IC50 value automatically calculated by FCS Express. And if we were to change the heat map gating options, it would affect these regression analysis. But better yet, we can change that right here with our other gate. These are all pooled wells of data, and as we change this other gate, it's going to change our analysis because this positive gate is applied to our individual pooled wells, and we can see how these regression analysis change for us in real time. The other added advantage to using this and using these tokens with heat maps is that if you're not the kind of person that just runs one heat map, that runs one plate at a time, maybe you're a more high throughput facility where you're running 10 plates a day, 100 plates a day, 10,000 plates a month, I don't know, depending on the size of your library. One thing that you can use FCS Express for is for batch processing, where in our data list you can bring in all of your plates worth of data, and if you had a similar, controls, compound 1, compound 2, control response, you can run all of your plates through FCS Express very quickly and easily and generate reports for that data. And these reports with the batch process, they can, again, go out to PowerPoint, they can go out to PDF. If you're running 1,000 plates, that's going to be a little bit of work to look at 1,000 PowerPoints, but we can also go out to things like Excel, or if you have a lab information system, FCS Express can be configured to directly export to your lab information system where you may be keeping the data analysis for your entire library of compounds that you're looking at. So there's a lot of different options for exporting this data from heat maps and high content analysis, whether it be flow cytometry or image cytometry, to just about anywhere you want to go. We do can offer some custom solutions for lab information systems as well, and I would encourage you to contact us if you have some of those custom systems or you have something that you'd like to look at in a custom system. So at this point, I'd like to open up the floor for questions. I think we've seen a lot about heat maps and high content today in the webinar. So if you have any questions for Cindy regarding highcontentreview.com or for myself, please enter them in the questions box. I want to give you a quick summary of some of the important points that we made today. One is that FCS Express is a very intuitive program that looks and feels like Microsoft PowerPoint, and this makes it really easy to use and to understand with your high content data. If you've ever used Microsoft Office, you should be able to come into FCS Express and use our heat maps and high content analysis. Also keep in mind that this high content analysis is also a very sophisticated report at the same time. All of the pages of analysis that you saw can be directly exported to PowerPoint or to PDF, or again, as I mentioned, to Excel. But what you see is what you get. They can always be formatted to change anything that you want and exported, rather than having to go through, say, something like Photoshop or PowerPoint to make those changes after you're done analyzing the data. And in the end, the analysis is very quick, it's easy, it's efficient, it can be done in a batch process. So if you have lots of plates, you can set up a template in FCS Express and just crunch your plates through FCS Express and let the data analysis or the numbers be spit out on the back end. And you can also run that batch process in a pause mode where you can come in and you can do that plate by plate or well by well quality control if need be. So again, at this point, I'd like to open up the floor for questions. I also want to mention that you can get your free 30-day trial of FCS Express with heat maps from the Novo software website. The Novo software website, you notice we have this download FCS Express free demo. And we also have a few other upcoming webinars, and you can always go and review this webinar at another time on our recorded webinars site. The other website I'd like to mention, again, is highcontentreview.com. Make sure to visit that website and register there with your account. It's a very, very useful website for finding information about your assays, keeping up to date about what is going on in the industry, lots of user insights as well as other information. Again, this is the High Content Review website. You can go there, www.highcontentreview.com. And I'm going to open up Cindy's microphone as well now. So thanks again, Cindy, for your presentation on highcontentreview.com. And is there anything you'd like to add?
Well, I'd just like to thank you for a very interesting presentation about heat maps.
Great. Well, thanks again, and we are going to be making this webinar available on the Novo software website, on the Novo software YouTube channel, and we expect to see it up on the highcontentreview.com website as well, so it's going to be a further resource for a lot of people in the field. And it looks like there's a few more questions coming in. We'll leave the floor open just for another minute or two if anybody has some questions. If you have questions after the webinar, you can find Cindy at www.highcontentreview.com. She's actively moderating that site. You can certainly contact her there. You can become a member and become her friend as well. Or you can contact support at denovosoftware.com with any of your FCS Express related questions. All right, and if there's no other questions, we'll end the webinar today. Thank you very much for attending the webinar. We hope everybody has learned something about working with heat maps, and we hope you can all visit the highcontentreview.com website as well. Thank you.